So the other thing that we're going to talk about in section 3.2, in addition to our empirical rule, is our z-score. So our z-score is going to give us a way to measure our distance from average. They are connected to our mean and standard deviation as well, just like our empirical rule is. And we're going to go through, we're going to talk about calculating them, how to interpret them, kind of what they mean, and how they can be used. Again, this is something that is definitely going to come up in multiple chapters throughout the semester. So just like our empirical rule, this is something that we want to get comfortable with when we're dealing with our mean and our standard deviation as well. Okay, so z-scores. So what z-scores are is they are actually something that we refer to as standard units. Standard units measure value relative to the sample rather than with respect to some absolute measure. A measurement converted to standard units is called a z-score, right, which measures how many standard deviations an observation is away from the mean. So the idea is here, we're not going to have labels on our numbers when we're thinking about z-scores. If we're talking about something in our problem, well, yeah, then we might have a label of pounds or centimeters or something along those lines. But what z-scores are going to do is it's going to give us a unitless, basically, way of measuring things. So when we're thinking about our z-score, it's going to tell us how far away we are from our mean, and it's going to tell us by using our standard deviations. So the z-score of the mean is always going to be 0. A positive z-score means the observed data value is greater than, or thinking about a number line to the right of the mean. And a negative z-score is going to mean that our value, our observed data value is less than or to the left of the mean. So we're going to look at a quick example just to kind of understand what we mean by these z-scores. Right, so using this given dot plot, the heights of 247 men marked with the z-scores as well as the heights in inches, answer the question below. A man who is 73 inches tall has a z-score of, well, if we look at 73 inches, we have a positive 1. We are 1 standard deviation from our mean. So that is going to be 1 standard unit. A man who is 61 inches tall. Right? So there we are -3. So we have -3 standard units, which means we are 3 standard deviations below our mean. How many men would have z-scores greater than 2 and less than 2? Right, so let's look at our picture. Greater than 2 standard deviations. Well, we only see 2 dots right here. So there's only 2 people that are greater than 2. And if we look at less than 2, right, we also only have 2 values here. Right, again, why we focus on 2 standard deviations is that what means that something is unusual. Right, so when we're thinking about our z-scores, that's also going to give us another way of answering the question, as we did in some of the previous examples, what is unusual? Because we're tied into our idea of our standard deviation and our mean and the connection between those 2 values.